Okay, now we're going to do example 5. Okay, so again, we're going to go through the same steps that we went through in the last example, but watch where we go with this one, okay? So it says to represent a rotation map, tau sub theta, where we're going to go from R2 to R2, so basically we're going to be rotating each vector in R2 by theta, okay? Through theta degrees, right? Or, you know, how do I say this? By rotating it through an angle of theta. Okay, now, again, just like before, we're going to start by fixing the standard bases. Okay, we're going to use epsilon 2 for both. Now, here's the difference. We're going to use the same basis for both the domain and the codomain. Okay, now we're going to find the image under the map for each vector in the domain's basis. Okay, so here's the one standard basis, or one standard vector, right? Basis vector, 1, 0. So that's going to give us cosine theta, sine theta. Okay, 0, 1 is going through the mapping. It's going to give us negative sine theta, cosine theta. Okay. Now we're going to represent these images with respect to the codomain's basis, right? So we're going to take these two images. We're now going to do like we did before. We're going to represent them with respect to the codomain's basis, but in this case they're the same. So the vectors are going to represent themselves, and then all we have to do is adjoin them, and we get the representative matrix for the map, tau sub theta. Okay. Now, here's the thing. The advantage to this scheme is that we get a formula for the image of any vector at all just by knowing this. Just by knowing that. Well, let me explain. By knowing how to represent in this, how to represent the image of the two basis vectors. Okay, so let's look at an example. Let's rotate a vector by pi over 6. Okay, so let's say we'll take the vector 3, negative 2. Okay, and we want to rotate this vector by pi over 6. Okay, now, so this is going to be equal to 3, negative 2 with respect to E2, or epsilon 2. Now, as we go through the mapping, right, so this is going to be T sub pi over 6. Now all we're going to do is we're going to input pi over 6 for theta. And so what are we going to get? Well, we're just going to take cosine of pi over 6, so it's a 30-degree angle, right? So all we're just going to use is what we know about our trig identities, trig functions, right? So we're going to get square root of 3 over 2. Okay. And then negative sine of 30 degrees is negative a half. And then sine of 30 degrees is positive a half. And then, of course, as we've seen before, cosine, so these are the same. So this is just going to be square root of 3 over 2. Okay. Now, we're going to multiply that by 3 negative 2. And what are we going to get? Well, we're going to approximately get for that one, again, having to deal with the square root of 3. Okay, and so that's what we get with respect to epsilon 2. And that's going to equal, again, it's just representing itself, so it's 3.598 minus 0.232. And that is our vector after it's been rotated, in this case, pi over 6. Now, if we do more general, right, because again, this is not going to change because we already know what the angle is. This isn't going to change. So if we want a more general formula, then let's just do it with xy. So this is going to be xy, 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 right? And so what we're going to do is now we get this formula where it's going to be what? Square root of 3x minus 1/2 y. And we get 1/2 x plus square root of 3 over 2 times y. And now we've got a formula for the rotation of any vector by, well, in this case, by pi over 6.